Hello everyone, myself Sheetal Gaikwad.
Myself, Disha Gule.
Myself, Ankita Jadhav from BIT, Bharati Vidyabit College of Engineering.
We are glad to present to you our final year project Smart Vision, Vision for the Visually Impaired under the guidance of Sonali Mhatre ma'am. So let's begin. There are about 285 million visually impaired people in the world. They are not able to experience the world the way we do. Smart Vision aims to provide this missing experience for them. The system uses state-of-the-art deep learning techniques from Microsoft Cognitive Services for image classification and tagging. The Smart Vision brings the beautiful world as a narrative to the scene in front of them to text, which describes the important objects in the scene. Next slide. The people with complete blindness or low vision faces many type of hurdles in performing everyday routine works. Blindness can occur due to many reasons, including disease, injury, or other conditions that limit vision. Our aim is to develop a navigation aid for the blind and the visually impaired people. This project aims to help the blind in object detection with the distance of the object and to provide an audio information about the object detected. The system helps the blind to navigate independently using real-time object detection and identification. Next slide. Let's talk about the methodology. When a user asks the voice assistant to describe the surrounding activities by saying, describe the scene, a webcam will capture the frame and send it to Microsoft APIs for recognition task. Once the image is recognized, the response is then inserted to DynamoDB in the form of a sentence and associated keywords. The captions and the keywords are fetched from the database DynamoDB, and the correct text is displayed as an audio using Google Text to Speech. The voice assistant works in two languages, Hindi and English, thus making it easy to use for a large number of audience. Next, the implementation would be shown by Disha.
Now let's move on to the implementation part. Firstly, this is the camera image.py file where we use the computer vision to recognize the image, for which we have imported the CV2 module. Then once the image is captured, it is stored in the Microsoft Azure. In this, the Microsoft API uses the request response type of model to describe the image and give the keywords. Then once the image is recognized, the description is stored in the output.txt file. And once this text is stored in this output.txt file, it can be stored in the cloud using AWS DynamoDB. To interact with DynamoDB, we have the Python module Boto3, which we have imported in voiceassistant.py. So we have created a user ID over here in the Amazon account. So after this, it can be stored in the cloud using the DynamoDB. And once the image is recognized, the description which is given by the Microsoft API, it will be stored in the output.txt file. Like here we can see, there is the description and these are the keywords which are assigned to it. Then we have used your speech recognition module to convert the text into audio, which will be narrated by the voice assistant when the user will ask for the description. And then we have the Python module English to Hindi, which is used to convert the English language to Hindi as per the user chooses the language according to it. So now let's see the working of this project.
Good evening, Sheetal. Choose a language, Hindi or English.
English.
This world is a beautiful place and I am here to help you see it with my voice. If you want to know what's happening around, say describe the scene.
Describe the scene.
I think it is a woman talking on phone. And the keywords are phone, indoor, woman, sitting, talking. Good evening Sheetal. Choose a language, Hindi or English.
Hindi.
यह दुनिया वाकई में बहुत खूबसूरत है और आप भी मेरी मदद से इसकी खूबसूरती का अनुभव कर सकते हैं। अगर आप जानना चाहते हैं कि आपके आसपास क्या हो रहा है तो हाँ बोलें।
हाँ।
मुझे लगता है कि यह एक महिला है जो फोन पर बात कर रही है।
Now the conclusion will be given by Ankita Jadhav.
Computer vision based solutions are emerging as one of the most promising options due to their affordability and accessibility. Its functionality addresses identification of objects and signboards. This will help the visually impaired people to manage day to day activities and to navigate through their surroundings. The system has a simple architecture that transforms the visual information captured using a camera to voice. The proposed system is cheap and configurable. The device is a real-time system that monitors the environment and provides audio information about the environment, making his or her navigation more safe and secure. So coming to the future scope part, light wearable and efficient glasses with a micro camera to capture images from the surrounding. We also have additional functionalities, which is text to speech for books, signboards and restaurant menu, indoor navigation with visual flam, outdoor navigation with GPS, traffic light color interpretation,